problem 4-11 from RC Hibbeler Engineering Statics 12th edition. According to this problem, we have to determine the moment of force about point O, and then we have to express the result as a Cartesian vector. So to solve this problem, first of all, we need the coordinates. For the coordinates of the points, for point O, it is the origin, so it's 0, 0, 0. Fit for point A, it is 1 in the x, 4 in the y, and 0 in the z-axis. For point B, I have 1, 4, 2 fit, and for the point C, I have 5 in the x-axis and 0 in the y and z-axis. So these are the coordinates. Then we have to resolve this force F along the line BC. For the force F into Cartesian vector form, F is equal to its magnitude and its direction, and we can find the direction by using unit vector along the line BC. So for the unit vector, I have position vector over its magnitude. UBC is equal to coordinates of point C minus coordinates of point B. So it is 5 minus 1, 4i plus negative 4j plus negative 2k divided by 4 square plus negative 4 square plus negative 2 square. From here, F is equals to, if I put the value of UBC in this equation, let's call this equation A, then F in terms of Cartesian vector form becomes 80i minus 80j minus 40k and I forgot to mention here that magnitude of force F is 120 lb. So we have resolved the force, but for the moment we have to find the moment arm. So for the 3D system, the only condition to find the moment arm is that the moment arm should start from the pivot point and should end on the line of action of force. So there is no need to draw a perpendicular line from the line of action of force. We just need to draw moment arm from the pivot point to any of the point on the line of axis of force. You can either draw the moment arm like this, or you can draw the moment arm like this. The answer would be the same. We can call it ROB, and this one is ROC, the moment arms. So if we consider M is equals to ROB into force F, and ROB is equals to coordinates of point B minus coordinates of point O. So it is 1i plus 4j plus 2k. This is the ROB, and force in terms of Cartesian vector form is also written here. So by using the determinant form of matrix. We have I, J, K. Then we have to write the moment arm 1, 4, 2, and beneath it we have to write force -80, -40. Expanding from R1, I mean row 1, the moment is equals to I 4 -80 2 -40 minus J 180 2 -40 plus K 1 4 -80 +80. Then I is equals to 4 into -40 -160 and negative into negative plus, so it is 160 plus. I have J -40 -8 -160 plus K into -80 minus 320. From here this term becomes 0 and this one becomes 200 J minus 400 K. This is the moment produced by the force F if we consider the moment arm R O B, and if we consider the moment arm R O C, the answer would be the same. So if I consider ROC right here for moment arm ROC into force F, then ROC is equals to coordinates of point C minus coordinates of point O. So coordinates of point C are 5, 0, 0. So I can write it as 5I plus 0J plus 0K. Then again by using the application of determinant, M is equal to I, J, K 5, 0, 0 and 80 minus 80 minus 40. This is the value of force F. Then again by expanding from R1, the raw one, I have moment is equals to I 0 -80 0 -40 minus J into 580 0 -40 plus K 580 0 -80. From here 0 into 40 is 0 and 0 into -80 is also 0, so it is 0. 5 into -40 it is -20 and 80 into 0 is 0 plus K 5 into -80 is 400 negative and 80 into 0 is 0. Again from here we have moment is equal to 200 J minus 400 K. So answer is same. Either you use ROB or ROC as a moment arm. I hope you will find this video helpful. If you do, please don't forget to subscribe this channel and also turn on the bell icon for the daily updates.